So the idea of these cross-sectional ones is the area is your base, like the shape that you see in 2 dimensions, that's the base of your shape. And from that base, technically we could have any shape possible coming up from that as long as you knew the area of that shape. So we started with squares and rectangles because those were the easiest areas that you know. And then we start to think, well, what are some other shapes that you know areas of? And we're going to look at triangles and semicircles. And the first one is an equilateral triangle. So we have to remember that this base here, this length would basically be your f of x minus g of x. That's equal to one side. And from that cross-section, right, when you do the slice, either perpendicular to the x-axis or perpendicular to the y-axis, from that we're going to go up and make a perfect equilateral triangle. And first of all, I'm going to say that almost none of you have your equilateral triangle formula memorized. Right? That's the first thing you thought of with area of an equilateral triangle? No. The first thing you thought of with a triangle is if you have to do the area, you thought, did you think base times height divided by 2? Right? Nobody had the 1/2 AB sine C1? No. Okay? You would most likely think of area of a triangle as base times height divided by 2. You would probably not have this one down. Okay? Do you remember that formula? No, you don't even remember that at all. That one's from grade 11. They're both very nice in this situation. I'm going to show you how we can get this formula for the area of an equilateral triangle using the ideas we already know. So using the ideas we already know, I'm going to label this as S and this is S. I'm going to draw a height, and since it's an equilateral triangle, that would make that side 1/2 S. How could you find the height? You could do a squared plus b squared equals c squared, right? You could do 1/2 squared, 1/2 s squared plus h squared equals s squared. You could get your h squared by itself by subtracting, and I'm going to square this out, and get 1/4 s squared. So my h squared is 3/4 s squared. Does that make sense?
Yep.
Or my h, if I get it all by itself, would be the square root of 3 over 2s. Okay? So now, what's the area of my triangle? 1/2. Base is s. Height is the square root of 3 over 2 times s. Does that area formula make sense to you now? We can multiply the halves on the bottom to get the 4 on the bottom. We have our root 3, and s times s is going to be s squared. Okay? You could also, just to review this formula, which by the looks of the blank faces meant that you forgot this 1/2 AB sine C formula. It's an area formula which uses 2 sides, A and B, and the angle in between them. So since this is an equilateral triangle, you would know this is 60 degrees. And since it's equilateral, both sides A and B are S. So our area formula would be 1/2 S times S times sine of 60 degrees. That's on your unit circle. What is sine of 60 degrees? Root 3 over 2. And we get our root 3 over 4s squared from that as well. In fact, I think that's more elegant than the a squared plus b squared equals c squared. A little bit less mental math even. Kind of right? If you pull out this formula, you're going to start feel a little bit impressed with yourself. It's like, ooh, I'm using an advanced area formula. Okay? So now we can do questions with areas of triangles, but what I wanted to do was just start off to show you that you don't have to memorize this formula. By all means, you can. I would much rather you have this formula memorized than that one. That one's useful in situations. The equilateral triangle area formula is going to be useful in these questions, but you can always figure it out, and it's not hard to figure out. And I always find if there's things you can figure out, don't use up your storage space, right? I only have 1 gigabyte. Don't use it up for things you don't need to.